one question that I think a lot of people have is you can't see it because it sucks all the light in, but if you could see it, what would it look like?
Oh, that's a really difficult question to answer. The details of the answer to that question, if I could answer it, would be to do with quantum gravity, which is not, as you know, an area of physics that has very many answers. We do think it's very, very small, but it turns out that we can't see any closer into a black hole, even in principle, any closer than this mathematical surface called an event horizon. If you're any closer than that, then the escape velocity that you would need to escape from the black hole exceeds the speed of light, which, as you know, is a pretty robust speed limit in the universe.
So once you're across that event horizon, you're committed. That's it.
It's game over as far as the external universe is concerned.
And I think one interesting thing about black holes is that, if I understand you right, they're a singularity in the classical general relativity. So that means that something different is happening. And yet, we don't know what exactly is happening at that inside. It's a quantum problem that we can't solve. We haven't solved. But yet we can derive all these other properties, like how you spin around it, that there's an event horizon. And it's kind of... Do you think that if we ever were to work out a quantum theory of gravity, would that have a big impact on what we think about black holes? Or
I wouldn't presume to say what the impact would or wouldn't be. Yeah. The history of this sort of field is that the phenomena are richer and more complex than we would imagine. I don't believe for 1 minute that black holes and the plasma jets, the relativistic plasma jets that squirt out from near them, would ever have been predicted from first principles by a clever theorist. Yeah. I just don't think that's the case at all.
We have to observe them.
For me, what you actually observe is quite an important component of the evidence on which our theoretical framework is based. And so to project forwards, I'm just hesitant about doing that. It would be terribly easy to be a little bit arrogant in this field and say, for sure this will mean that. But I think arrogance can come together with not knowing very much, because these things are a little bit difficult to observe. We can't see them with our own eyes. Yeah. We can't see them directly in any case. They do seem to behave and operate in a way that reflects many different laws of physics, and so to presume that if our understanding improved in one particular direction, that everything would come unlocked is something I wouldn't wish to claim.
There might be big surprises.
The history of this field does suggest that there are a great many surprises out there.
So black holes are kind of crazy.
They absolutely are. And I don't believe that we could have predicted any of their detailed behaviour from first principles. Although, in fact, they were first conjectured by a rector in West Yorkshire in the late 18th century by a chap called John Mitchell. He was a rector, he was a polymath. He loved thinking about life, the universe and everything, geology, astronomy, theology. And he conjectured that if you had a star that was massive enough, then light wouldn't be able to escape away from it. His conjecture was a little bit primitive by modern standards, but he'd made the conceptual leap. Maybe it might be possible for there to be something out there which was sufficiently massive that light couldn't escape from. But that was years before, a century before general relativity, of course.